Hey there, Mrs. Williams here, and this is question 4.1.A-2. And we're starting off with part F of this question, because this is where it starts to get a little bit harder. So you see some fractions involved within fractions, because what we're trying to find is the pulley ratio of pulley A to pulley B. So I wrote the fraction over here that we're trying to create, and in column F, 4 3/8 is the diameter of pulley pulley A, and 1 3/4 is the diameter of pulley B. And so I'm going to place the 4 3/8 in the numerator and the 1 3/4 in the denominator. So in this type of problem, it looks kind of crazy. You have a mixed fraction within a fraction, so lots of fractions. But we want to just take one part at a time, so we're just going to focus on the numerator and convert that mixed fraction to an improper fraction. So that's what I'm showing here. We're taking the 8 times 4, adding 3, 4 times 8 plus 3, over the current denominator of 8 right here. And then we're going to go through the same process for the denominator. So 4 times 1 plus 3, 4 times 1 plus 3, all over the denominator of 4. Okay, so again, this looks messy, but it's going to look better in a second. Once we simplify the numerator, we get 35 over 8 all over 7 over 4. And really what we have now is division of two fractions, 35 over 8 divided by 7/4. So the rule when you're dividing fractions is copy dot flip. You copy the first fraction, or the fraction in the numerator, you put a dot, and then you flip the bottom fraction over. So instead of 7 over 4, so we're going to have 4 over 7. And what you're doing now is multiplying. So one thing you can do, you can just multiply straight across, but you can also make this a little bit easier before you multiply by cross-canceling. So 4 and 8 have a common factor of 4. So 4 goes into 8 twice, 4 goes into 4 once. And 35 and 7 also have a common factor. It's 7. 7 goes into 7 once. 7 goes into 35 5 times. And now if we multiply what's left, we have 5 times 1, which is 5. And we have 2 times 1, which is 2. And this is the ratio of A to B. This is a fraction. We've just simplified this fraction up here and made it look much, much better and gotten it down to a very simplified form. And so this is our A, and this is our B. So the ratio is 5 to 2. All right, so let's keep going on part G of this question. So again, we're trying to make the ratio, or the pulley ratio of A to B. So we're going to put pulley A's diameter over pulley B's diameter. So that's what I have here. And again, this looks kind of messy because we have decimals within our fraction. So one thing we can do to make this a little bit easier is to multiply the top and the bottom by 100. And the reason the reason I chose 100 was I'm looking at this decimal. This is the decimal that has the most numbers to the right of the decimal point. And I can see that there are 2 place values to the right of the decimal point. So when I multiply by 100, what's going to happen is this decimal point gets moved over to the right 2 places, and I'm going to get rid of my decimal. So I end up with 1,136. And the same thing in the denominator. And I'm just going to place a 0 here where as a holder, and so I get 1,420. So at least that gets rid of my decimal. Now, if we treat this like any other fraction and we just say, okay, I have a fraction, but I always want to make sure it's in lowest terms, these both have a common factor of 284. So if I divide the top and the bottom by 284, then I can simplify this down to 4/5. And then again, this is my simplified ratio. So I started out with my ratio, but really what I'm doing in part F and part G is just trying to make it simplified so that it's in a nicer form, where I'm just ending up with a whole number over another whole number rather than a bunch of crazy decimals or fractions mixed in there. And so this is my A, and this is my B in the pulley ratio. So the ratio is 4 to 5. Okay, and then we'll try H here as well. So again, now I put this in here just so you could see what the final answer would be, but originally this was, because you could see where the gray boxes are, that's what you're looking for. So this we didn't know. So this is a little more challenging, but I'm going to start out by writing the ratio of A to B. So the ratio of diameter A we know is 20.54. The ratio of diameter B we don't know. I'm going to put an X there. Now if you think about what we did in this problem, for example, we started out with the ratio of the pulley diameters, but we manipulated it. We multiplied by 100, we divided by 284, but really this is equal to 4/5. So this beginning fraction of diameter of pulley A over diameter of pulley B is equal to the fraction that you're making over here in your third column. So because I'm missing this value in this problem, I can make it equal to this ratio of the pulley ratio of A to B. So I can say this is equal to 3.16 over 1. I know that those are going to be equal, and that's going to help me find that missing diameter of pulley B. Now, I could do this a few different ways. I think the easiest way to go about this one is to think about what you would do to get from 20.54 to 3.16. Now, that's probably not real easy to figure out off the top of your head, but you can just take, because think about like what we did here. If we're going from a larger number, we went from 1,136, simplified that down to 4, what we were doing was dividing by a number. So we're going from 20.54 and somehow simplifying it to 3.16. So there has to be some division going on here. Well, dividing by what? Well, if you actually take the 20.54 and divide it by 3.16, that'll give you this number. It ends up being 6.5. So again, all I did to find that number was I took 20.54 divided by 3.16 on my calculator, and that gives you 6.5. So now I say, okay, well, how would I get from x to 1 dividing by 6.5? Because whatever you do to the top, you have to do to the bottom so that you're not changing the value of the fraction. Well, work backwards. If you say, okay, well, if I need to know this number, whatever this number is, if I divide it by 6.5, I get 1. So go backwards to find out what that is. I can take 1 times 6.5, and that is 6.5. That's what this number has to be. Now, that works out because this is a 1. If this was 2, then this would be a 13, or if this was 3. So that's not, it's just kind of coincidence that you're dividing by 6.5 and that this ends up being 6.5 just because this is a 1. So just a heads up, it's not always going to be the same as what you're dividing by. But in this case it is, and if it's something different, something other than 1, you can just, again, work backwards and multiply 1 by the number you're dividing by to find out what that original value would be. So that's where the 6.5 came from. Okay, so let me know if you have further questions.